Okay. Alright, so at the very top, can you tell the geometric sequences? Left hand side, I'd like for you just to write just the word geometric. Okay. So for geometric, we're going to discuss this whether it's a sequence or a series. So I'll just write that. So it's a sequence or series where you multiply or divide each term by a, and I'm going to put this next thing in quotations. It's actually called a common ratio. I'm going to put an R right next to it. Okay. So in arithmetic sequences, we had common difference, right? That was noted by the letter D, so that was something that we added or subtracted. For common ratio, you're multiplying here, and that's noted by the variable R. Okay. I'm going to give you two examples where, now the thing is, you don't represent this as multiply by something. You don't write the multiplication symbol, you don't write the division symbol. So I'm going to give you two quick examples. So off to the left over here, so we're going to have 3, 6, 12, and 24. Dot, dot, dot. Is this a sequence or a series?
A sequence.
It's a sequence. Now the thing is, what is the pattern to the sequence?
Multiply.
Yeah, so you're multiplying by something. So you're going to put R equal to 2. Okay. You do not have to write the actual multiplication symbol. Like the thing is, R already has the idea that you're going to be multiplying. Like this is different than this. What does D equal to 2 mean?
It's a difference.
Yeah, and this means that we're adding 2 versus this means we're multiplying by 2. Okay, so just the variable that you set, you should understand whether you're multiplying or dividing. Now I'm going to give you a different sequence, and this one's going to be decreasing. Around 25, 5, 1, 1/5, and then 1/25. What's happening here? Divide by 5. Now the thing is, the way that we represent this is R equal to 1/5. Okay. Now over here, this represents dividing by 5, just the way that 1/3 represents dividing by 3, or 1/4 represents dividing by 4. Okay. And actually, when we worked on Name That Pattern on Monday, I think Nadia actually mentioned it. There was a pattern where we're like dividing by 3, I think. And then, Nadia, do you remember what you said?
It was like 1/4.
Yeah, so it was like dividing by 4, and you said, is that the same thing as multiply by 1/4? It's the same thing. So divide by 5 is also the same thing as multiply by 1/5.
So, will R ever be a negative number?
It could be, yeah. Let's say this. So that's a good example. Let's say we had negative, positive, negative, positive.
Oh, okay.
The common ratio would be a -2, right? If you multiply by a negative, you have this oscillation of negative, positive, negative, positive. Okay. Yeah, I don't think I've included any of those examples, but that can happen. All right. Okay, so on the left-hand side, I want you to take this. Go ahead and glue this underneath here.
First it's Skylar.
Skylar. Oh, Skylar.
You look lonely.
So we're gonna see how this video goes. I think if it's kind of like useful. Oh, that is not true at all. If it's kind of useful, I think this might be like a common occurrence, maybe especially for this class, because there are no videos for last year for geometry or this year for algebra 2. I've kind of neglected you guys in that sense. All right. So since this is a sequence, this will find any term in the sequence. I want you to write equal to. So what's going to happen is I'm going to show or write what is the formula. So for this, it'll be a sub n off to the left. Okay. And right over here, so you're going to have equal to. This next 5 is going to be a sub 1. And what we're going to do is, since this deals with the idea of multiplying, we're going to I'm going to put a dot in between these two to indicating that we're multiplying. We're going to multiply that times R. And there's a specific way that I want you to write this next thing, because R is actually going to be raised to an exponent that exponent is n minus 1. So when you write it, can you please write it as if it were an exponent, like off to the top right?
Then why don't we put it in parentheses?
You could put it in parentheses. The reason that we put like arithmetic sequences in parentheses is because you're actually multiplying it by something. So causing the distributive property.
So n minus 1 is
Is
r the exponent?
Well, like how?
Yes, that n minus 1, both terms are the exponent.
Isn't that in the arithmetic?
That is actually represented in arithmetic sequence.
In the formula.
Good. So if you look at this, the arithmetic sequence is this. So this is actually what you had on your. Ooh, I can't see.
On our
Alright. There are some kids that haven't taken the quiz. So if you notice, this is the same. You also deal with the first term. Instead of ratio, you deal with difference. And instead of multiplying, we're actually going to represent this as an exponent. And I think this will become clear when we actually derive it. Alright, open up all the flaps. We're going to discuss what every single thing represents. Flaps. Alright, a sub 1 represents the nth term. You guys see that?
Yeah.
Oof. Whoa. Like a whole person. Okay. Now, right over here, a sub 1 represented the first term. Okay. What is represented by r? What does r mean?
The common ratio.
Good. So it's the common ratio. When you look at a sequence, pretty much it's just the pattern, the common ratio. And the last one, well, this is just going to be, it is a power, it is an exponent. So I'm going to write this. I'm going to write 1 less than the number of terms. And in parentheses, I'm going to put power. Right? This is represented as a power. Hope you don't think like this is multiplying here. Okay, questions on what any of these values represent? Alright, go ahead and close this. We're going to be using this formula. Alright, left hand side, this is the end of our notes. It's going to be example. I'm actually going to use one of these sequences that I just wrote above here. I'm actually going to use the sequence, the 3, 6, 12, and 24. The first sequence that we wrote, right up here. Okay, just like how in arithmetic sequences, we first had to identify a couple of things. I'm going to write a question underneath here. It's going to be, what is the 15th term? Alright, so let's find a couple of things. Typically you'll want to find what is your first term, what is your common ratio, and what is the n. Our first term in the sequence is what? 3. We already found our common ratio. That was 2. And what is our n in this case? 15, right? Number of terms, well, we're going to find the 15th term. Okay. We'll move this off to the right. Go ahead and rewrite that formula. So a sub n is equal to a sub 1 times r to the n minus 1. Okay. Making sure that you write that at the top right. And let's fill in what we know. So I'm going to put a sub 15. That's our n. Instead of a sub 1, we found that our first term was 3. Our common ratio is 2. And to the n minus 1, so 15 minus 1. Okay. If your r is ever if it's ever negative, typically you'll see like a parentheses around here. Okay. Order of operations, what are we going to do first?
Exponents.
Exponents, right? So we're going to simplify our exponents. So let's put 3 times 2 to the 14th power now. And I'm going to just explain, this is a common occurrence, is that students will rewrite this as 6 to the 14th power. Why is that not right?
Because
You have to do 2 first.
Yeah, so order of operations, you have to do the exponent before you multiply. So do not multiply first. You have to leave this alone. Now 2 to the 14th power, what does that mean?
2 times
2 times
2 times
itself 14 times.
Wow. So 2 times itself 14 times. That's a huge number. What I'm going to do is I'm just going to give you that number. Unless you guys want to figure it out.
No.
Alright. Alright, so we're going to have 3 times, and this is represented as 16,384. So I'm going to tell you something that my Algebra 1 students did. They actually found out 2 to, well, like one student figured it out. 2 to the 64th power.
Oh no.
It was like 5 quintillion. So they had to do a lot of multiplying here. When you guys are multiplying, I trust that you guys can
Why
multiply.
would you do that?
It was for like a.
Why would you put
No.
yourself
It was like a 7th grade though. All right, now multiply this by 3, so it's going to be 49,552. So we're going to have a sub 15. Go ahead and box that. So what this is represented, now look at this. It starts out pretty easy, right? 3, 6, okay, it's fine. 12, 24, or it's getting a little bit bigger. If you go 15 numbers,
How does it
it'll be that big. It'll be 49,152. That'll just be the 15th term. Okay. The reason is because you're constantly doubling here. Okay. I think some of you guys saw like my Algebra 1 students like folding pieces of paper, and the record that we could get was 10. Because when you fold a long stretch of paper like we had through this entire corridor, half of that, or if we fold it, that's half the distance, like it decreases super fast. This increases super fast. What I'm going to do is I'm going to quote, like there's this famous lyric. Okay, like it starts out with really, really small numbers. So it's started from the bottom, and now we're here. Okay. The thing is, it's like you started from the bottom, and now the whole team is here. Okay, like all like this number is super huge. You have to be careful with this, because this will increase super fast. With this will get into like exponential functions. Exponential functions increase super fast. But that's the only example that I want to go through for now. Can you put this off to the side? Because what I'm going to do is I'm going to first derive it. So keep this formula out. You guys can see this. Like, why is this formula here? All right. All right, don't get distracted. All right, so this is going to be the derivation. So the arithmetic sequence, geometric sequence formula is this. There's a reason it's this. Okay, now I'm going to use that last sequence that we had. Okay, what we like to do, or what I like to do, is actually we kind of like hyper-analyze every single term. Okay, so I'm going to put a sub 1, a sub 2, a sub 3, a sub 4. All right, the first term is 3. This will be 6, 12, and 24. You care about two things. You care about the first term, and you care about the common ratio. Okay, this is 3. What was the common ratio? 2. I would like to represent all these things with only 2's and 3's, or 3's and 2's. How can you represent 6 as 3's and 2's?
3 times 2.
3 times 2. 12?
3 times 2 times 2.
3 times 2 times 2. And 24.
3 times 2 times 2 times 2.
You guys make like a good horror movie. Like, it sounds very ominous. Okay. Now the thing is, there's a better way to represent these 2's here, right? 2 times 2, 2 times 2 times 2. Let's go. I'm going to start at the end. How can we represent 2 times 2 times 2? 2 to the third. 2 to the third. So this is actually 3 times 2 to the third. This is 3 times 2 to the
second.
This is 3 times 2 to the first. How can you represent this one?
3 times
3 times 2 to the 0, right? Anything to the 0 power is just 1, right? And 1 times 3 will just then be 3. So the actual formula here, notice how all these things started with a 3. What was represented by our 3?
Oh, I wasn't.
A sub 1. Notice how all these things have bases of 2's. What was represented by 2? R, the common ratio. That was the pattern. And notice this. Notice like the numbers right over here to the exponent. So the number over here, the fourth term, had an exponent of 3. The third term, exponent of 2. Second term, exponent of 1. It's always 1 less than it. How do you represent 1 less than it?
N minus 1.
To the n minus 1. Okay, and that's it.
I just had a flashback to the pyramid thing.
Alright, so does this make sense on how it's derived?
Yes.
Okay, hopefully it makes some sense. Alright, so take out your markers. We're going to get to practicing 2 examples, and then I think to our assignment.
My awesome
Yep.
marker.